All right. So in 8.4, we're going to continue to talk about ratios that exist in right triangles. So we had tangent from last time, and now we're doing sine and cosine. So the sine of an angle is the ratio of the opposite leg to the hypotenuse. So remember last time I told you the hypotenuse is never the leg or the adjacent. Okay, so again, if this is my angle here, okay, that's my angle. This would be the opposite of that angle, okay, to go across. And the hypotenuse is still the hypotenuse, okay? And this is the adjacent. Again, if I'm going from this angle, if I was doing this angle, we would have to switch these around. The hypotenuse is always going to stay the same. So again, just like with the tangent, the ratio of the opposite side to the hypotenuse of a right triangle, when you divide those two sides together, you'll get a certain number. And no matter how big or how small the triangle is, if that degree is there, that ratio will exist. And that kind of helps us because it's in a right triangle. We can figure out a lot of missing parts. And trig functions are used in a lot of different ways we're going to learn in the next section. So now this is where these other two columns come in. And you have to start to try to decide, which of these do I want based on which information I have? Do I know a hypotenuse? Do I know an opposite? Do I know an adjacent? And that's going to help you choose which of these functions to use. Okay, a way commonly people remember it is SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So again, that would be the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. So a lot of people will splash that down at the top of their quiz. I think they have some made up little stories about that too. Important part, do not spell it wrong. Okay, I'm not kidding. I've had people do it before. Don't spell it wrong. All right, so again, I have the answers here, but feel free to pause and try them yourself on your blank and then come back and check them later. Now, in this one, if you have the printout of the notes, I think I may have had T here. Change that to an R. Okay, so just double check if you have the printout of my notes that it matches up with what I have on the screen. So again, write the triangle, use the triangle to write each ratio. So the sine of R, I'm going to go to angle R, and sine is opposite to hypotenuse. So I'm going to go opposite the R, so that's 8. And the hypotenuse is 17. For the cosine of R, okay, here's angle R. I'm going to go adjacent, it's the leg that helps make angle R, to the hypotenuse, 17. So that's where that came from. Now for the sine of G, G is up here. I'm going to go opposite G, 15, over hypotenuse, 17. And for cosine of G, I'm going to go adjacent, that's over here, to hypotenuse, which is 17. And I could find the angles as well. And sine and cosine are in your calculator as well, just like they were with tangent, so you should really use your calculator for those. So over here, have a right triangle. I need to find two missing legs. I can't use Pythagorean theorem. I don't have enough sides. It's not a special right triangle, so I can't use that. So I'm going to use my trig functions. So I'm going to start here to get x. Here's 67. And there is more than one way to do this. It's just I don't have time to talk through all the ways in a video. So I'm going to say, okay, the x is opposite the 67. So I'm looking for opposite. And what was I given? I was given the hypotenuse. So I'm looking for the opposite. I have the hypotenuse. Which trig function goes with opposite and hypotenuse? Sine. So I said the sine of 67 is x over 120. So basically, again, I'm looking for what number that when I divide it by 120, let's see, the first column is sine, will I get 0.9205? What number when I divide it by 120 will give me this number right here, the sine of 67? Okay, so I multiplied both sides by 120. This is exactly what I would type in my calculator, this exact thing right here, and I get 110.5. When I'm looking for side y, I'm going to use the 67 again. I do not recommend using Pythagorean theorem with this side you calculated in the 120. Remember, you rounded this. And because you rounded that, you're going to lose accuracy on what y actually is if you use rounded numbers. So when I want y is adjacent to 67. And again, I'm going to use the hypotenuse. So I want adjacent, I have hypotenuse. Okay, great, that's cosine. So now I'm looking for what number, when I divide it by 120, will give me 0.3907. Okay, that's in the cosine column. Or again, you can set it up this way. Your calculator already has all this. So I set up the equation. I multiplied both sides by 120. I got my answer. Over here, I did the same idea. Opposite, I was given the hypotenuse. That's why I picked sine for x. And for the 28-degree angle, y was adjacent. And again, I was given the hypotenuse. To be accurate, I'm going to use the number they gave me, not a number I calculated and rounded earlier. And I got 882.9 for that. In the last slide, we're finding angles. Again, look at where the measurements are. So again, I'm just going to base it on what I have. So when I look at angle N, I have the side opposite and I have the hypotenuse. So which goes with opposite and hypotenuse? Sine. So if I'm looking for an angle, you can write this down if you want. Whenever you look for an angle, that's when you use your inverse or your -1, sine to the -1. Again, you're telling your calculator here's the ratio, what's the angle that goes with it. So you type this exact thing into your calculator. If you were doing it the, shall we say, classic way, you would do 18 divided by 30 on your calculator, and you would look up where that is. So I get 0.6 for that. And if I look in the sine column for 0.6, it looks like it's about a 53-degree angle. Oh, wait, I was in the wrong column, sorry. 0.6 in the sine column. So 0.6 in the sine column is 37. The sine column is the first one. And so 37. And same idea here. Again, you have to look at what you have to decide. There's not like every time I guess it is kind of every time. So here's N. I have the adjacent. I have the hypotenuse. Which trig function goes with adjacent hypotenuse? Cosine. I used inverse cosine. That's 57 degrees. Okay? So that concludes the notes for this section. It's just kind of applying it with new ratios.